In this video, we will learn how to find the point elasticity of demand from the given revenue function. The question is total revenue from the sale of a commodity is being given us, or is total revenue which is equal to 100x minus 2x square. X denotes our quantity. Find the point elasticity of demand when marginal revenue is 20. The options are 0.5, -1, -1.5, and -2. We need to find out the point elasticity of demand. So what we are being given? We are being given the total revenue, or is equal to 100x minus 2x square. This is our total revenue function. Now what is the formula for point elasticity of demand? So elasticity of demand is being given by change in quantity with respect to price into P upon Q. This is the formula for price elasticity of demand or point elasticity of demand. Okay, we are being given the revenue function. So first we need to find out the inverse demand function. This is our revenue function. Also we are being told that uh, marginal revenue is equal to 20. So let us find first here what is marginal revenue. Marginal revenue is simply the derivative of total revenue function with respect to output. Take the derivative of this function with respect to x. Derivative of x is 1, so we are left with 100 minus derivative of x square is 2x, so 2 2s are 4x. This is our marginal revenue, but marginal revenue is also given as 20. Marginal revenue is this function, marginal revenue value is 20. Then that means our 100 minus 4x should be equal to 20. Okay, we have same LHS, so we can equate RHS. Solve for x here. Okay, we have 4x will be equal to transposing this 4x on this side, so 100 minus 20 comes out to be 80, which implies our x will be equal to 80 upon 4, which gives us 20 as output. So our output will be equal to 20. Okay, but we need to find out the demand function. As we know that total revenue is equal to price into output. Okay, so that means price into output will be equal to, but total revenue is being given as this, that means P into X should be equal to 100x minus 2x square. Simple thing. If this is our total revenue function, and we also know total revenue is equal to price into output, so equating this P into X with the revenue function, which will give us, so we have here P into X is this, we can write it like this, P into X is equal to, take X common here, we are left with 100 minus 2x. Now cancel x and x. Okay, so we got P is equal to 100 minus 2x. Now we need to solve it for x. So transposing this 2x here, we are left with 100 minus P, or x is equal to, transposing this 2, it will get divided to each of these terms, so 100 upon 2 is 50 minus P upon 2. This is our demand function. Okay, so we don't need first we found out the inverse demand function, then we write the demand as a function of price. Okay, which is our normal demand function. We need to find out dq, and in place of dq we have x. Okay, we have denoted output with x, so here we have also x. So taking derivative of this, we have dx upon dp. If I take the derivative of this function with respect to price, derivative of constant is 0, derivative of p is 1, so we are left with minus 1 upon 2. Okay, and what is price? Also we need to find out the price. We got output is equal to 20, then what, rather we will write it as it is. So x is equal to 20. Now elasticity of demand will be equal to dx upon dp. We got it as minus 1 upon 2. And what is p? P is being given as 100 minus 2x. It is not given to us, we have derived it upon x, the value of x is 20, and here also the value of x will be 20. So I will say one step here. So we have minus 1 upon 2 into 100 minus 2, 20s are 40. So 100 upon 100 minus 60, sorry, 100 minus 40 comes out to be 60 upon 20. This gets cancelled. We have 2 ones are 2 threes are 6. We got minus 3 upon 2, which comes out to be minus 1 upon, sorry, minus 1.5. This will be our point elasticity of demand. Okay, so the C option should be correct. I hope I make myself clear. Thank you.